Hello everybody, my name is Josh. I was a computer science examiner. I was also a head of computer science in UK schools, and also I run a tutoring business, and I've helped thousands of students to get better grades in computer science. Now, what this series is all to do with is giving you as little as possible to remember whilst being able to still access those top grades. And I use my experience as an examiner to think about all of the questions that could potentially come up to give you a really good shot at getting those top grades. The topic we're looking at today is compression. This is relevant to every single specification, but there's some minor tweaks. So AQA, you have to know about Huffman trees and run length encoding, and Cambridge International, you also have to know about run length encoding. So we'll go through everything that's relevant to those specifications, and then I'll add in the little extra bits that are applicable to those specifications. Just make sure that you're on the right video so you get everything that you need to know. So the first part is we need to make sure that we understand actually what compression is and why do we use it. So compression is an algorithm. You don't need the bit in brackets, but just in case you don't know, step-by-step list of instructions to do a task, and it's an algorithm to make file size smaller. With that, why do we need compression? Essentially with compression, what we need with this is it's going to make the file size smaller. So if we're going to put something on a network, it's going to make it, if we send it over there, we don't need as much bandwidth. It also is generally going to make it so that we don't need as much storage space on our device. So there's two reasons as to why we use compression. The next parts are looking at the specific types of compression. So there's two that you need to know, which is lossy and lossless. So if it says what is lossy compression is an algorithm which makes the file size smaller. And how it does it by permanently removing parts of the file that are not easily seen, e.g. reducing the color depth, so you reduce the amount of colors, or heard, so you reduce the audio bit depth. Now, if the question specifically says how does lossy compression work on an image video, make sure that you use the color depth example. If it said to use it for a sound file, then you need to talk about how it's heard, so the audio bit depth, because it's specific to the question. So you need to make sure that you apply the right scenario to it. So the next question is, what is lossless compression? This is the idea about how we're making the file size smaller, and what it allows you to do is create the original file on the other side. So what it does is it looks for repetitions in text, pixel color, and sounds, and condenses them all together. So that's the general idea of lossless compression. Now, you're probably thinking, why would you ever use lossless? Or why would you ever use lossy over lossless if you have to permanently change the file? Now, there are two particular reasons as to why you would use these, and also you have to think about, you may get a scenario and then you have to make sure that you pick the right one and give reasons as to why you would use that one over the other. So the main advantage of lossy over lossless is you get generally a much bigger data reduction than lossless. Lossless's main advantage over lossy is it gives you the original file, and if the example that it was looking for is it was a coding file, so it had computer program code, we cannot use lossy compression, because lossy compression is going to permanently change that file, and as you imagine with coding, when you've been learning that, it has to be exactly the same. So we have to use lossless than in that example. So here's a scenario. So it says John needs to send over a photo to an online art gallery. Which compression method do you suggest and why? Lossless, so state the example. Lossless would be my suggestion, because an online art gallery needs the best quality image possible. So again, I'm relating it to the scenario. That's so important that you relate to the scenario and make a comment about the situation that we're in. And lossless allows you to recreate the image exactly as the original. So for the AQA and Cambridge International specifications on GCSE computer science, what we have to do is we have to be able to change text, pixels, sounds, and using run length encoding and show what the output would look like. So the idea with this, of what we're trying to do, is we're trying to look for repetitions. So this question here is we've got the word Mississippi, and what we're going to do is use run length encoding and show what the data is going to look like once we have finished the process. So first of all, I look at what you do is you take the first letter. We don't have any repetition, so I'm going to put a 1. So you put the number first and then the letter. If that was a yellow pixel, you'd put yellow pixel. Or if that was a sound, you'd put that there. So 1M. Then the next one is an I. So it's going to be 1I. Oh, it's quite similar. Now, we've got 2 S's. So we're going to put 2 S. Then I put another 1I. 2 S, and just do this whole process of going through the whole word. 2 P 1 I. Okay, so that's the whole word there. Now I slightly tweak this one to show you the process of what you need to do if you're given a word and you have to process this using run length encoding. The follow-on question to this is why run length encoding isn't actually very good at processing this and making it compressed. So the problem with this is, as you can see, there's not what are called long runs. So if we add S's but 10 S's in a row, this would actually save us a lot of space, and that would be brilliant. In this case, the longest ones that we've got are the S's, and they're only in groups of 2. So it's not really going to help us too much when we're trying to compress this file and make it much smaller.